They had calculated it was impossible. Japanese naval planners, sitting in their offices in Tokyo during the summer of 1941, had run the numbers repeatedly. American shipyards, they concluded, could never build fast enough to replace losses from submarine warfare. The mathematics seemed irrefutable. A standard cargo vessel required 18 months from keel laying to launch. Even the Americans, with their vaunted industrial capacity, could not overcome basic shipbuilding physics. Admiral Isoroku Yamamoto knew the American industrial potential better than most of his colleagues. He had served as a naval attaché in Washington and traveled extensively through American industrial centers. He had seen the automobile factories in Detroit, the steel mills in Pittsburgh, the vastness of American manufacturing capacity. Yet even Yamamoto, when pressed by his staff officers about American shipbuilding capabilities, agreed that merchant ship construction remained bound by traditional timelines. You could not simply will a ship into existence. Hulls required careful riveting, engines needed precision assembly, systems had to be tested. The process was sequential, methodical, time-consuming. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Japanese naval staff had studied American shipyard capacity in detail. In 1940, the United States possessed approximately 50 shipyards capable of building ocean-going merchant vessels. These yards, operating at normal peacetime capacity, produced roughly 500 ships per year of all types. Many of these were small coastal vessels, tankers, or specialized craft. True cargo-carrying merchant ships suitable for long-range transoceanic voyages numbered perhaps 200 annually. The Imperial Japanese Navy planned to sink American merchant ships faster than American yards could replace them. Japanese submarines would operate in the Pacific, targeting supply lines between the American West Coast and forward bases. The Tonnage War, as it was called in naval planning circles, would strangle American logistics. Without merchant shipping, the United States could not sustain military operations across the vast Pacific. Raw materials could not reach American factories. Finished weapons and supplies could not reach American forces. The calculations seemed sound. If Japan could sink 300,000 tons of American shipping per month, and American yards could only produce 200,000 tons monthly, the gap would widen inexorably. Within 2 years, American merchant capacity would be crippled. Within 3 years, it would be effectively destroyed. The plan had historical precedent. German U-boats in the First World War had nearly succeeded in starving Britain through unrestricted submarine warfare. Only the implementation of the convoy system in 1917 had prevented British collapse. The Japanese studied those lessons carefully. They understood that merchant shipping was the vulnerable artery of any maritime power. Sever that artery, and the enemy would bleed resources until they could no longer sustain military operations. What the Japanese planners did not know, could not know, in the summer of 1941, was that their entire strategic calculus rested on assumptions about shipbuilding that were about to become obsolete. They assumed ships required traditional construction methods because ships had always required traditional methods. They assumed construction timelines were fixed because those timelines had remained largely unchanged for decades. They assumed American shipyards would operate according to the same principles, using the same techniques, following the same procedures that had governed shipbuilding since the age of steam. The Japanese were designing their naval strategy around sinking ships that would soon be built faster than anyone thought possible. But in 1941, as Japanese carriers prepared for their strike on Pearl Harbor, no one yet knew that American shipyards were about to be revolutionized by methods borrowed not from naval architecture, but from factory assembly lines and prefabricated construction. The ships that would help win the Pacific War had not yet been designed. The yards that would build them had not yet been constructed. The workers who would weld their hulls together had not yet been hired. The revolution in shipbuilding that would render Japanese calculations meaningless was still on drafting tables, and in the minds of engineers who understood that speed of production mattered more than elegance of design. Admiral Yamamoto had warned his government that Japan could run wild for 6 months, perhaps a year, but that he had no confidence in ultimate victory against American industrial power. His warning was prescient. What he could not foresee was how quickly that industrial power would adapt, how radically American methods would change, how completely traditional shipbuilding assumptions would be overturned. The story of that transformation begins not with ships, but with the men who reimagined how ships could be built. The British needed ships desperately. By the spring of 1941, German U-boats were sinking British merchant vessels faster than British yards could replace them. The Battle of the Atlantic was reaching its crisis point. Convoy losses mounted steadily. In March 1941 alone, U-boats sank 41 merchant ships totaling over 236,000 tons. In April, 43 ships went down. In May, 58 ships. The British merchant fleet was being systematically destroyed. Britain's survival depended on imports. Food, fuel, raw materials, weapons, everything Britain needed to continue fighting arrived by sea. If the merchant fleet collapsed, Britain would be forced to negotiate peace regardless of Churchill's determination to continue the war. The British government approached the United States for assistance. Could American shipyards build merchant vessels for Britain? Could they do so quickly enough to offset the losses? The United States was not yet at war. The Neutrality Acts constrained American assistance to belligerent nations. But President Franklin Roosevelt and his advisers understood that British survival served American strategic interests. If Britain fell, the United States would face the Axis powers alone. Finding a way to help Britain remained essential. The solution came through creative legal interpretation and the Lend-Lease program, which Roosevelt signed into law in March 1941. The program allowed the United States to transfer weapons and supplies to nations deemed vital to American defense. Britain qualified immediately. Under Lend-Lease, American factories could produce weapons for Britain. American shipyards could build ships for British use. The legal obstacles were removed. The practical obstacles remained formidable. American shipyards were already operating near capacity, building ships for American merchant lines and beginning construction of naval vessels for the expanding United States Navy. Adding British merchant ship orders to existing workloads seemed impossible. Someone would have to build new shipyards. Someone would have to design ships simple enough for rapid mass production. Someone would have to recruit and train workers by the tens of thousands. Someone would have to revolutionize shipbuilding methods that had remained largely unchanged for generations. That someone was Henry John Kaiser, an industrialist whose background contained no experience whatsoever in shipbuilding. Kaiser had made his fortune in construction. He had built roads, dams, and bridges across the American West. He had managed massive public works projects, including significant portions of the Hoover Dam and the Grand Coulee Dam. He understood large-scale industrial processes, logistics, and mass production techniques. He had never built a ship. When the British Purchasing Commission issued contracts for American-built merchant ships in 1940, established shipyards on the East Coast and Gulf Coast submitted bids. These were traditional yards with experienced workers, established methods, and deep knowledge of maritime construction. Kaiser submitted a bid as well, proposing to build ships on the West Coast where his construction companies were based. The British were skeptical. Kaiser's company had no shipbuilding experience. His proposed yard in Richmond, California, did not yet exist. His timeline seemed impossibly optimistic, but Kaiser's bid was competitive on price, and the British needed every ship they could get from any source. They awarded him a contract for 30 cargo ships, with the understanding that Kaiser would have to build the shipyard before he could build the ships. Kaiser approached shipbuilding the way he had approached dam construction. He studied the problem systematically. Traditional shipyards built ships sequentially, one piece at a time, assembled in place. Each ship occupied a building way for months, while workers fabricated and installed components. The process was slow because it was sequential. Workers could not install engines until the engine room was ready. They could not complete the superstructure until the hull was finished. Everything happened in order, step by step. Kaiser proposed a different method borrowed from automobile manufacturing and prefabricated construction. Why not build the ship in sections at different locations, then assemble those sections on the building way? Engines could be installed in engine room sections at a separate facility. Crew quarters could be completely finished as prefabricated modules. Entire sections of hull could be welded together away from the building way, then lifted into place by crane. The ship would spend minimal time occupying the building way. Construction time would be dramatically reduced. The idea was not entirely new. Some shipyards had experimented with modular construction techniques, but no one had attempted to apply these methods on a massive scale with workers who had no previous shipbuilding experience. Kaiser was proposing to industrialize shipbuilding, to treat a 10,000-ton cargo ship not as a carefully crafted vessel built by skilled maritime craftsmen, but as a mass-produced industrial product assembled by factory workers following standardized procedures. The Richmond shipyard began construction in December 1940. Kaiser's construction crews, experienced from years building dams and highways, worked rapidly. They graded the site, drove pilings, poured concrete foundations for building ways and fabrication shops. By April 1941, barely 4 months after breaking ground, the yard was operational. The first keel was laid. The design Kaiser chose for his ships came from British specifications. The British needed simple, reliable cargo vessels that could be built quickly with minimal specialized materials. The design they provided was based on an older British tramp steamer with a reciprocating steam engine rather than modern turbines. Reciprocating engines were less efficient but simpler to manufacture. The ships would be slow, making perhaps 11 knots maximum speed, but they would be sturdy and adequate for cargo hauling. The design was deliberately unsophisticated. These ships would not win any awards for naval architecture. They were blunt-bowed, slab-sided, utilitarian vessels designed purely for function. British merchant sailors, accustomed to more elegant ships, would later describe them as ugly ducklings. American maritime unions, reviewing the plans, declared the ships obsolete before they were even built. Kaiser did not care about elegance. He cared about production speed. The simpler the design, the faster his workers could build it. The more standardized the components, the easier they could be mass-produced. The fewer specialized skills required, the more quickly new workers could be trained. He was not trying to build beautiful ships. He was trying to build ships fast. The workforce Kaiser assembled reflected his unconventional approach. Traditional shipyards employed workers who had apprenticed for years learning maritime trades. Ship fitters, marine electricians, pipe fitters, these were skilled craftsmen with specialized knowledge. Kaiser could not recruit enough skilled workers to staff his new yard. The traditional maritime labor pool was already employed. He needed to find workers elsewhere and train them quickly. Kaiser recruited from everywhere. He hired construction workers from his dam projects. He recruited farmers from the Midwest. He brought in unemployed workers from Depression-era relief programs. Most significantly, he hired women in unprecedented numbers. American shipyards before the war employed virtually no women in production roles. Kaiser hired thousands of women, trained them in welding, pipe fitting, electrical work, and every other trade needed in shipbuilding. By 1943, women would constitute significant portions of the workforce in Kaiser's yards. Some became among the most skilled welders in the facility. The training programs Kaiser developed were intensive but brief. Traditional shipyard apprenticeships lasted years. Kaiser's training programs lasted weeks. Workers learned one specific task, perfected that task through repetition, and performed that task repeatedly on multiple ships. A welder might spend months doing nothing but welding deck seams. She would become extraordinarily proficient at that one specific task through constant repetition. Another worker might specialize in installing piping in engine rooms, performing the same installations on ship after ship until the work became automatic. The approach was pure industrial mass production applied to shipbuilding. Each worker was a specialized component in a larger assembly process. No single worker needed to understand the entire ship. They only needed to master their specific task and perform it efficiently. Critics from traditional maritime backgrounds were appalled. This was not shipbuilding, they argued. This was factory work. The ships produced by these methods would be inferior, they warned. Vessels built by semi-trained workers using simplified techniques would fail at sea. The maritime unions protested. Kaiser ignored the critics and continued hiring and training workers. By mid-1941, Richmond Shipyard No. 1 was producing ships. The first vessel, a cargo ship for Britain, launched in September 1941. It had taken approximately 9 months from keel laying to launch. This was faster than traditional construction, but not yet revolutionary. Kaiser was still learning. His workers were still gaining experience. The revolutionary acceleration in construction time would come later, as the system refined itself through experience and as Kaiser built additional shipyards incorporating lessons learned from the first. The system Kaiser developed became more sophisticated with each ship. The key innovation was modular prefabrication on an unprecedented scale. Traditional shipyards fabricated some components off the building way, but Kaiser took this approach to its logical extreme. He divided each ship into hundreds of prefabricated sections. These sections, called assemblies and sub-assemblies, were constructed in separate fabrication shops spread across the shipyard. A deckhouse might be completely finished in one shop, with all interior fittings, electrical wiring, and plumbing installed before it ever moved to the ship. Engine room sections arrived at the building way with engines already mounted and much of the auxiliary machinery already connected. Hull sections came as complete panels, not individual steel plates. Workers in the fabrication shops could work in comfortable conditions with proper lighting and tools arranged for efficiency. They were not crouched in cramped ship compartments or working overhead on scaffolding. They performed their tasks at optimal working height with maximum efficiency. The building ways themselves became assembly points rather than construction sites. Massive cranes lifted the prefabricated sections into position. Welders joined the sections together. Within weeks, hundreds of separate components became a complete ship. The speed improvement was dramatic. By late 1941, Kaiser's yards were completing ships in 6 months. By mid-1942, the timeline had dropped to 3 months. By 1943, some ships were launching in less than 2 months from keel laying. The record would eventually be held by the SS Robert E. Peary, which launched in November 1942 after just 4 days and 15.5 hours from keel laying to launch. That particular ship was a publicity stunt, built with extra workers and special attention to demonstrate what was possible. But even routine production by 1943 was completing ships in 40 to 50 days. This was not 4 times faster than traditional methods. This was 10 times faster. The ships Kaiser built were called Liberty ships, a name chosen for its patriotic resonance. The design was finalized in early 1941 based on British specifications with American modifications. The Liberty ship was 241 feet long and 37 feet in beam. It displaced approximately 14,000 tons, fully loaded. The hull was all welded rather than riveted, a crucial decision that enabled prefabrication. Welding allowed sections to be joined quickly. Riveting required drilling thousands of holes and individually installing each rivet, a time-consuming process, unsuited to rapid construction. The welded hull construction generated controversy. Traditional shipbuilders preferred riveting, arguing that riveted hulls were more flexible and better able to withstand stress. Welded hulls, critics warned, might crack under load. The concerns proved partially valid. Some early Liberty ships did experience cracking, particularly in cold weather when hull plates became brittle. Several ships suffered catastrophic failures where cracks propagated through welded seams, splitting the hull. The most notorious was the SS Schenectady, which broke completely in half while docked in calm water in January 1943. The ship had been in service only 6 weeks. Investigators determined that the combination of cold weather, poor welding technique in some seams, and stress concentrations at certain hull features had caused brittle fracture. Kaiser and other builders responded by improving welding procedures, adding crack arresters to hulls, and, redesigning certain structural elements to reduce stress concentrations. The problem was never entirely eliminated, but it was reduced to manageable levels. Most Liberty ships served reliably throughout the war despite the concerns about welded construction. The Liberty ship carried a crew of 44 men, including deck officers, engine room crew, and general seamen. It could carry approximately 10,000 tons of cargo in 5 holds. The cargo capacity was sufficient for roughly 440,000 cubic feet of material, whether military equipment, food, fuel, or raw materials. Range was approximately 17,000 miles at economical speed, sufficient to cross the Atlantic or Pacific without refueling. The ships were armed for defense against aircraft and submarines. A typical Liberty ship mounted a 5-inch gun on the stern, a 3-inch gun on the bow, and numerous 20mm and 37mm anti-aircraft guns. Navy armed guard crews manned these weapons. The armed guard typically consisted of 8 to 15 Navy personnel assigned to each merchant ship for defensive purposes. The Liberty ship's steam reciprocating engine was deliberately archaic. Modern ships used turbines for better efficiency and higher speed, but reciprocating engines were simpler to manufacture and required less specialized steel. American industry could produce reciprocating engines in any machine shop capable of heavy manufacturing. Turbines required specialized facilities and materials that were needed for warships. Kaiser and the Maritime Commission chose the older technology specifically because it could be mass-produced without straining specialized industrial capacity. The engine produced 2,500 horsepower, driving a single propeller at approximately 77 revolutions per minute. This gave the ship a maximum speed of 11 knots, about 12.5 miles per hour. Loaded Liberty ships crossing the Atlantic typically maintained speeds of 10 to 11 knots. They were slower than almost any warship afloat. But speed was not the priority. Cargo capacity and construction speed mattered more than operational speed. A slow ship that could be built in 6 weeks was more valuable than a fast ship requiring 6 months to construct. By mid-1942, Kaiser was operating multiple shipyards. Richmond Shipyard No. 2 opened, followed by a massive complex in Portland, Oregon, and another in Vancouver, Washington. Other companies adopted Kaiser's methods. Todd Shipyards, Bethlehem Steel, and numerous smaller companies began building Liberty ships using prefabrication techniques. The Maritime Commission, the government agency overseeing merchant ship construction, standardized Liberty ship production across multiple builders. Drawings, specifications, and construction procedures were shared freely. Companies that developed improvements shared those innovations with competitors. The normal competitive secrecy of private industry was suspended. Everyone was building the same ship using the same methods, and everyone benefited when any builder discovered a better technique. The result was continuous improvement in construction speed and quality. Workers grew more skilled through repetition. Procedures were refined. Equipment was improved. Supply chains were optimized. The learning curve effect operated at massive scale across the entire industry. By late 1942, American shipyards were launching Liberty ships at rates that would have seemed impossible a year earlier. In December 1942 alone, American yards delivered 95 Liberty ships. That was 95 10,000-ton cargo ships in a single month, nearly 1 million tons of new shipping capacity added in 30 days. The Japanese naval staff began receiving reports of American ship production in mid-1942. The numbers seemed impossible. Intelligence analysts questioned the data. American shipyards, according to pre-war assessments, could not possibly be producing ships this quickly. The reports must be exaggerated, perhaps through deliberate American disinformation or through faulty intelligence gathering. Someone was making errors in counting, perhaps confusing ship launchings with ship completions, or perhaps counting smaller vessels alongside ocean-going cargo ships. Admiral Yamamoto reviewed the intelligence reports with his staff. The numbers troubled him. If even partially accurate, they indicated American production far exceeding Japanese assumptions. He ordered additional intelligence collection efforts focused on American shipyards. Japanese submarines were tasked with observing ship traffic patterns. Intelligence officers analyzed American radio traffic for shipping movement reports. Captured documents were examined for production data. By late 1942, the evidence was overwhelming. American shipyards were, indeed, producing cargo ships at extraordinary rates. The construction timelines were genuine. Ships were launching weeks after keels were laid. Multiple shipyards were operating simultaneously, each producing ships on assembly line schedules. The total monthly production was approaching and would soon exceed 100 ships. Japanese pre-war calculations had assumed American yards might build 200 cargo ships annually if operating at maximum capacity. The Americans were now building that many ships every 8 weeks. The implications were staggering. Japan's submarine force could not possibly sink ships faster than American yards were building them. The tonnage war was lost before it had properly begun. Every merchant ship Japan sank would be replaced within days by new construction. The American supply line across the Pacific could not be severed by submarine warfare because the Americans were simply building too many ships. If one ship was sunk, 2 more were already sliding down, building ways to replace it. Japanese naval leadership struggled to comprehend how this was possible. How could ships be built so quickly? What methods were the Americans using? Japanese naval architects studied captured documents and intelligence photographs of American shipyards. They identified the prefabrication techniques, the modular construction, the assembly line processes. But understanding the methods did not mean Japan could replicate them. Japan's shipbuilding industry was structured differently, based on traditional methods and skilled craftsmen. Japanese yards built fewer, more sophisticated ships using time-intensive techniques. Japanese industrial capacity was already strained by warship construction for the Imperial Navy. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. There was no excess capacity to build merchant ships using any method, let alone to construct entirely new shipyards dedicated to mass production. Japan's merchant fleet was being steadily attrited. In 1942, Japanese merchant losses totaled approximately 1 million tons. In 1943, losses would exceed 1.8 million tons. In 1944, losses would exceed 3.8 million tons. Japan began the war with approximately 6 million tons of merchant shipping. By mid-1944, more than half would be sunk. Replacements were not keeping pace. Japanese yards were building merchant ships as quickly as their capacity allowed, but total production in 1943 was only approximately 769,000 tons. The Americans were building that much shipping in less than 2 months. The disparity was incomprehensible by pre-war Japanese assumptions. One nation was building merchant ships 10 times faster than the other nation could sink them. The mathematical foundation of Japanese naval strategy had collapsed. Yet, the war continued. Japanese forces fought on across the Pacific, with supply lines growing increasingly tenuous as their merchant fleet was systematically destroyed. Islands that had been supplied regularly in 1942 received only sporadic shipments by 1944. Garrisons were cut off, starving, running out of ammunition and medical supplies, because there were not enough merchant ships to supply them, and the ships that did sail were being sunk by American submarines at increasing rates. The strategic implications of Liberty ship production extended beyond simple tonnage replacement. The ships enabled American strategy in ways Japanese planners had not anticipated. With merchant shipping available in abundance, American forces could project power across vast distances without worrying about supply line sustainability. Every invasion in the Pacific required enormous quantities of supplies. The invasion of Saipan in June 1944 involved transporting and supplying 71,000 troops across 3,000 miles of ocean. They required food, ammunition, fuel, medical supplies, spare parts, construction materials, and every other item needed to sustain military operations. This required hundreds of cargo ships making repeated voyages. The Americans had those ships. They had enough ships to supply ongoing operations while simultaneously building up supplies for future invasions. They could operate multiple offensives simultaneously across the Pacific because merchant shipping was not a limiting factor. Liberty ships carried the bombs that B-29s dropped on Japan. They carried the fuel that American aircraft burned. They carried the ammunition that American artillery fired. They carried the food that American troops ate. Every aspect of American military operations depended on merchant shipping, and that shipping was available in quantities that exceeded requirements. American forces in the Pacific never experienced supply shortages due to lack of shipping capacity. Individual items might be scarce due to production limitations or distribution problems, but the ships to transport supplies were always available. Japanese forces, by contrast, operated under constant supply constraints. Garrisons went hungry because supply ships were sunk. Operations were cancelled because fuel could not be delivered. Aircraft sat grounded because ammunition ships never arrived. The merchant fleet that was supposed to sustain Japan's Pacific Empire was disappearing beneath the waves faster than it could be replaced. By 1944, Japanese merchant losses had become catastrophic. American submarines, operating from forward bases and equipped with improved torpedoes, were sinking Japanese ships at will. American submarines sank approximately 600 Japanese merchant ships in 1944, totaling over 2.3 million tons. This was approximately 3 times Japan's entire annual shipbuilding capacity. The mathematics were brutal. Japan was losing ships at 3 times the rate it could build replacements. The merchant fleet was being liquidated. By 1945, Japan's merchant marine had been functionally destroyed. Ships that survived were huddled in ports, afraid to venture into waters patrolled by American submarines. The supply lines connecting Japan to resource areas in Southeast Asia were severed. Oil from the Dutch East Indies could not reach Japan. Rubber, tin, rice, and other strategic materials remained in Southeast Asia because there were no ships to transport them. Japan's economy began collapsing from resource starvation. Factories closed because they lacked raw materials. Synthetic fuel programs could not meet demand. The population faced food shortages as rice imports ceased. The strangling of Japan's merchant fleet, which Japanese pre-war planning had assumed would be inflicted on American supply lines, was instead inflicted on Japan itself. And the instrument of that strangling was not primarily combat action, though American submarines were devastatingly effective. The instrument was industrial capacity. America built ships faster than Japan could sink them. Japan lost ships faster than it could replace them. The equation was simple and decisive. Admiral Yamamoto had been correct when he warned that Japan could not win a protracted war against American industrial power. What even he had not fully anticipated was how quickly that industrial power would manifest. Within 2 years of Pearl Harbor, American shipyards were producing merchant vessels at rates that made Japanese tonnage warfare strategy obsolete before it could take effect. Japanese admirals, who had mocked American shipbuilding capacity and calculated that merchant ship losses would cripple American logistics, found themselves presiding over the destruction of their own merchant fleet while American cargo ships crossed the Pacific in endless convoys, their numbers seemingly inexhaustible, their construction pace accelerating rather than slowing as the war progressed. The human cost of Liberty ship production is often overlooked in discussions of industrial statistics. The ships were built by workers who labored under difficult and sometimes dangerous conditions. Shipyard work was physically demanding. Welders worked in cramped spaces wearing heavy protective equipment. Riveters, in yards that still used riveting, endured constant noise that could cause permanent hearing damage. Workers installing equipment in unventilated compartments breathed paint fumes, welding smoke, and asbestos dust. Safety standards were less stringent than modern requirements. Industrial accidents were common. Workers fell from scaffolding, were struck by falling equipment, or were injured by machinery. Some were killed in crane accidents when heavy loads broke free. Others died from falls into ship holds or from being crushed between moving sections during assembly. The Richmond shipyards, where Kaiser's operations were headquartered, experienced numerous fatal accidents during the war years. The exact numbers vary by source, but dozens of workers died in industrial accidents across Kaiser's yards during wartime production. Thousands more were injured seriously enough to require medical treatment. The pace of work contributed to accident rates. Shipyards operated around the clock in 3 shifts. Workers were under constant pressure to maintain production schedules. Safety procedures were sometimes shortcut in the push to complete ships quickly. Fatigue was common, especially among workers putting in overtime hours. Tired workers made mistakes that sometimes proved fatal. Yet workers continued volunteering for shipyard employment in enormous numbers. The wages were good by wartime standards. The work was considered vital to the war effort, carrying a sense of purpose and patriotism. And for many women, shipyard work represented opportunities for employment and advancement that had not existed before the war. Women workers in Kaiser's shipyards earned the same wages as men performing the same tasks, an unusual situation in 1940 America. They worked as welders, electricians, pipe fitters, and in virtually every skilled trade. Some became supervisors, managing work crews and coordinating production. The most famous was Wendy the Welder, a propaganda figure based on real women workers and used to encourage female participation in industrial work. Actual women welders in Kaiser's yards produced welds that consistently passed quality inspections. Some became among the most skilled welders in the facility. Their work was indistinguishable from that of male welders, and ships they worked on performed reliably in service. After the war, most women workers were laid off as men returned from military service and reclaimed industrial jobs. The wartime opportunities largely evaporated. But during war years, women comprised significant portions of shipyard workforces and contributed directly to the production achievements that helped win the war. The Richmond shipyards at peak production employed approximately 90,000 workers. This was an enormous industrial workforce concentrated in a relatively small geographic area. Housing became a critical issue. Richmond's pre-war population had been approximately 23,000. The sudden influx of shipyard workers overwhelmed existing housing stock. Kaiser's company built worker housing developments, temporary structures designed for quick construction and wartime durability. Thousands of workers lived in these developments, small apartments or dormitories within walking distance or bus ride of the shipyards. The communities that grew around Kaiser's shipyards were microcosms of wartime America. Workers came from across the country. Rural Southerners worked alongside urban Northerners. White, black, Hispanic, and Asian workers labored side by side, though segregation persists in some facilities and discrimination was common. The shipyards were more integrated than much of American society, but they were not free from the racial tensions that characterized the era. Despite these tensions and the difficult working conditions, the workforce produced ships at rates that astonished contemporary observers. By 1943, American shipyards were collectively launching a new Liberty ship approximately every 8 hours. That pace continued through 1944. The cumulative total grew relentlessly. 500 Liberty ships by late 1942, 1,000 by mid-1943, 1,500 by late 1943, 2,000 by mid-1944. The final Liberty ship, the SS Albert M. Bow, launched in October 1945 after the war had ended. Total production, 2,710 Liberty ships built in approximately 4 years. Was not counting the other merchant ship types being built simultaneously, including the larger Victory ships, tankers, and specialized vessels. The Liberty ships alone totaled over 30 million tons of shipping capacity. To understand what 30 million tons of shipping capacity meant in practical terms, consider that the entire Japanese merchant fleet at the start of the war totaled approximately 6 million tons. The Americans, in Liberty ships alone, built 5 times Japan's entire pre-war merchant marine, and they did it while simultaneously building warships, aircraft, tanks, trucks, and every other item needed to wage industrial warfare on a global scale. Japanese industry could not compete. This was not a failure of Japanese workers or engineers. Japanese shipbuilders were skilled and competent. Japanese naval architects designed excellent warships. The issue was systemic. Japan's industrial base was approximately 1/10 the size of America's. Japan's access to raw materials, particularly after 1943, was increasingly constrained by submarine warfare and blockade. Japan's manufacturing methods were based on craftsmanship and quality rather than mass production and quantity. Most fundamentally, Japan had not prepared for the kind of war it was actually fighting. Japanese pre-war planning had envisioned a short war, decisive victories in the first 6 months, followed by negotiated peace before American industrial power could fully mobilize. Admiral Yamamoto's warning that Japan could run wild for 6 months but had no confidence thereafter proved devastatingly accurate. By mid-1942, American industrial mobilization was gaining momentum. By 1943, it was operating at full capacity. By 1944, American production was overwhelming Japanese capacity across every category of military equipment. The Liberty ships were merely the most visible example of this disparity. American factories produced 300,000 aircraft during the war. Japan produced approximately 76,000. American factories produced nearly 90,000 tanks. Japan produced approximately 6,000. American factories produced 2 million trucks. Japan produced approximately 165,000. The ratios varied, but the pattern was consistent. American production exceeded Japanese production by factors of 5 to 15, depending on the specific equipment category. This was not a war Japan could win through fighting spirit or tactical excellence. Material superiority of this magnitude was decisive. Japanese soldiers fought with extraordinary courage and determination. Japanese tactics were often innovative and effective. Individual Japanese equipment items were sometimes superior to American equivalents. None of it mattered when facing 10-to-1 production disparities. The Liberty ships symbolized this industrial dominance. They were not elegant vessels. They were not fast or sophisticated. They were functional, mass-produced cargo carriers, built by semi-trained workers using simplified construction methods. And they were built in such enormous quantities that they rendered Japanese tonnage warfare strategy completely ineffective. Every Liberty ship that arrived in the Pacific carried supplies that sustained American military operations. Every Liberty ship that successfully completed its voyage proved that American supply lines could not be severed. Every Liberty ship that was sunk, approximately 200 were lost to various causes during the war, was immediately replaced by 2 or 3 more sliding down building ways. Japanese submariners, prosecuting their attacks on American shipping, faced impossible mathematics. They could sink ships courageously and skillfully, and they did sink hundreds of Allied vessels during the war. But they could not sink ships faster than American yards built them. The equation was simple and brutal. One nation could build 10 merchant ships in the time another nation could sink one. That nation would win the tonnage war regardless of tactical outcomes. By 1945, Japan's merchant fleet was functionally extinct. Survivors huddled in ports or operated only at night in coastal waters, hoping to avoid American submarines that patrolled Japanese waters with near impunity. The flow of resources to Japan had slowed to a trickle. Oil imports, which had totaled approximately 5 million barrels per month in 1941, had effectively ceased by mid-1945. Japan's synthetic fuel programs could not meet demand. Aircraft were grounded, ships remained in port, training programs were curtailed. The Japanese economy was being starved of the resources needed to continue fighting. Meanwhile, American merchant ships operated across the Pacific in convoys so large they sometimes stretched to the horizon. Supply dumps at forward bases overflowed with equipment and materiel. American forces never lacked supplies. If anything, they often had excess capacity. Food was abundant, sometimes wastefully so. Ammunition was plentiful. Fuel was available for every operation. Medical supplies ensured that wounded soldiers received the best available care. The contrast with Japanese supply situations was stark and demoralizing to Japanese soldiers who survived to be captured. Prisoners of war consistently expressed shock at the abundance of American supplies. One Japanese officer, captured on Okinawa, told interrogators that he had not believed American propaganda about industrial capacity until he saw supply dumps with his own eyes. Mountains of supplies, more equipment than his entire regiment had possessed, casually stacked and apparently inexhaustible. He realized then that Japan had no chance of victory. The industrial disparity was too great. The Liberty ships that carried those supplies across the Pacific had been mocked by Japanese naval planners who calculated that American shipyards could never build fast enough to sustain transoceanic supply lines under submarine attack. Those planners had been wrong in almost every assumption. Wrong about construction timelines, wrong about American industrial methods, wrong about the willingness of American industry to abandon traditional practices in favor of mass production techniques, wrong about the ability to train unskilled workers to perform complex industrial tasks, wrong about the strategic implications of merchant shipping abundance. The consequences of being wrong were catastrophic for Japan. The nation's strategy for winning, or at least surviving, the war depended on severing American supply lines through tonnage warfare. When that strategy failed because American shipyards were building ships 10 times faster than Japanese submarines could sink them, Japan had no alternative strategy. The war became one of attrition, and attrition favored the nation with greater industrial capacity by overwhelming margins. After the war ended, many Liberty ships continued in service. Some were sold to commercial shipping companies and operated for decades in merchant service. Others were placed in reserve fleets, anchored in various harbors as strategic reserves that could be reactivated if needed. Some were scrapped, some were sunk as artificial reefs or targets. A few survive today as museum ships or stationary facilities. The SS Jeremiah O'Brien, built in 1943, remains operational in San Francisco as a museum ship. The SS John W. Brown, built in 1942, operates from Baltimore as a memorial and educational vessel. These surviving ships offer physical evidence of what wartime mass production achieved. Visitors can walk their decks, examine their cargo holds, see their engine rooms, and try to imagine the industrial effort that produced 2,710 such vessels in 4 years. The workers who built Liberty ships returned to civilian life after the war with mixed experiences. Many found that wartime opportunities did not translate to peacetime employment. Women workers were laid off in large numbers as men returned from military service. Shipyard employment plummeted as production contracts ended. The massive industrial workforce that had built the ships dispersed to other industries or other regions. Some workers retained skills learned in the shipyards and found employment in post-war industries. Welders, electricians, and other tradespeople could apply their training in construction, manufacturing, or other fields. Others returned to agricultural work or service industries. The wartime shipbuilding boom had been a temporary mobilization, not a permanent economic transformation. Kaiser himself transitioned to other industries after the war. His companies moved into aluminum production, steel manufacturing, and construction. He founded Kaiser Permanente, a health maintenance organization that grew into one of America's largest healthcare providers. The organizational and management techniques he had applied to shipbuilding proved transferable to other industries. His legacy extended far beyond the ships his yards had produced. The Liberty Ship program demonstrated several important principles that influenced post-war industrial practices. Mass production techniques could be applied to complex products previously built using traditional craftsmanship methods. Modular construction and prefabrication could dramatically reduce assembly time. Unskilled or semi-skilled workers could be rapidly trained to perform specialized tasks if those tasks were broken down into manageable components. Quality need not suffer from mass production if proper procedures and inspections were implemented. These lessons influenced post-war manufacturing across multiple industries. Automobile production, already highly rationalized, became even more efficient. Construction techniques incorporated more prefabrication. Heavy industry adopted modular approaches where applicable. The principles that had built Liberty ships in weeks contributed to the post-war economic boom that transformed American living standards. For Japanese observers studying the war's outcome, the Liberty ships represented a painful lesson about industrial capacity and strategic planning. Japanese military leadership had underestimated American industrial potential and overestimated Japan's ability to disrupt American supply lines. The consequences were decisive. Post-war Japanese economic planning emphasized industrial development and manufacturing efficiency. The nation that had lost the production war became, within decades, an industrial powerhouse known for manufacturing quality and efficiency. Toyota's production system, developed in the 1950s and refined over subsequent decades, incorporated lessons about efficiency and quality control that had parallels to American wartime production methods. The irony was profound. Japan learned from its defeat and built an industrial economy that became the world's second largest by the 1980s. The Liberty ships themselves, ugly ducklings that no one had loved aesthetically, proved remarkably durable. Ships that maritime experts had predicted would fall apart after a few years of service sometimes operated for 20 or 30 years. Their welded hulls, once criticized as dangerously fragile, proved adequate for peacetime merchant service, where they were not overloaded or operated in extreme conditions. The simplicity that made them easy to build also made them easy to maintain. The reciprocating steam engines, derided as obsolete when installed, proved reliable and easy to repair. Many Liberty ships outlasted more sophisticated vessels built using traditional methods. The design that had been chosen purely for rapid production turned out to be a robust and practical cargo carrier. This was perhaps the final irony. The ships built, as temporary expedients, designed to be good enough for wartime service and nothing more, proved to be genuinely useful vessels that served merchant fleets worldwide for decades after the war ended. Henry Kaiser, who knew nothing about shipbuilding when he started, had somehow gotten the essential elements right. By focusing on function over form, simplicity over sophistication, and quantity over individual quality, he had created vessels that met their intended purpose and then exceeded expectations by continuing to serve long after their anticipated lifespan. The Japanese admirals who had mocked American shipbuilding capacity and calculated that merchant ship construction would limit American strategic options had been confronted with an industrial revolution they did not foresee and could not counter. Traditional assumptions about shipbuilding timelines became obsolete when American industry applied mass production principles to maritime construction. The 18-month construction cycle that seemed like an immutable fact became an 8-week assembly process through prefabrication and modular construction. The skilled craftsmen that seemed essential for quality shipbuilding were replaced by semi-trained workers performing specialized repetitive tasks. The elegant vessels that maritime tradition demanded gave way to functional cargo carriers designed purely for utility. Every assumption was challenged, every tradition was questioned. The result was an industrial achievement that materially contributed to Allied victory by ensuring that supply lines remained open, resources flowed freely, and military operations never faced limitations due to shipping capacity. In the calculus of war, this mattered enormously. The strategic lessons of Liberty ship production extended beyond World War II and influenced Cold War thinking about industrial mobilization. American military planners recognized that future conflicts might require rapid industrial expansion. The ability to quickly build ships, aircraft, tanks, and other military equipment could prove decisive. Programs were established to maintain surge capacity, the ability to rapidly increase production in response to military emergencies. Reserve fleets of merchant ships were maintained specifically to provide shipping capacity if needed. Industrial facilities were designed with the capability to switch from civilian to military production. Workers were cross-trained on equipment that might be needed for defense production. The Liberty ship experience had demonstrated that industrial capacity was a strategic weapon as important as any military technology. This recognition shaped American strategic thinking for decades. The Soviet Union drew different but related lessons. Soviet military planning emphasized mass production of simple, robust equipment that could be manufactured in enormous quantities. Soviet military doctrine assumed that numerical superiority would compensate for any qualitative disadvantages. This philosophy, already evident in Soviet World War II production of 34 tanks and other equipment, was reinforced by observing American production achievements, including Liberty ships. For smaller nations, the lessons were more troubling. No nation with limited industrial capacity could hope to prevail in extended conflict against an industrial superpower. Wars would be decided not primarily on battlefields but in factories. The nation that could outproduce its opponent would ultimately win regardless of tactical outcomes. This realization shaped military planning and alliance structures throughout the Cold War era. The Liberty ships themselves faded from headlines after the war. They were workhorses, not glamorous vessels. They received no parades or celebrations. Workers who built them returned to civilian life without fanfare. The ships themselves were sold, scrapped, or mothballed with minimal public attention. Yet their impact on history was profound. They enabled the projection of American military power across vast distances. They sustained military operations that would otherwise have been impossible. They proved that industrial capacity could be mobilized rapidly when national survival demanded it. They demonstrated that traditional methods could be revolutionized when circumstances required new approaches. The 2,710 Liberty ships built between 1941 and 1945 represented more than 30 million tons of shipping capacity. But they represented something more significant than mere tonnage. They represented the application of industrial mass production to complex engineering problems. They represented the mobilization of a civilian workforce, including groups previously excluded from industrial work, to achieve production goals that seemed impossible by traditional standards. They represented the triumph of pragmatic functionality over aesthetic elegance. They represented American industrial capacity operating at full mobilization. Most fundamentally, they represented the answer to Japanese pre-war assumptions about American shipbuilding capacity. The admirals who had calculated that merchant ship construction timelines would limit American strategic options had been proven catastrophically wrong. The ships that Japanese naval planners believed would take 18 months to build were launching in 8 weeks. The production rates that seemed impossible by pre-war assumptions became routine by 1943. The industrial capacity that Japanese leadership had underestimated proved decisive. When historians analyze why Japan lost the Pacific War, they cite many factors. The loss at Midway, which eliminated carrier parity, the code-breaking that gave Americans intelligence advantages, the island-hopping strategy that bypassed Japanese strongholds, the submarine campaign that destroyed Japan's merchant fleet. All of these were important. But underlying all of them was industrial capacity. America could replace losses. Japan could not. America could sustain operations across vast distances. Japan could not. America could equip its forces with abundant supplies and equipment. Japan could not. The Liberty ships, unglamorous cargo carriers built by workers who had never before built ships, embodied this industrial superiority. Every Liberty ship that crossed the Pacific carried the material means of American victory. Food, fuel, ammunition, equipment, vehicles, aircraft, and every other item needed to wage industrial warfare arrived in the holds of these mass-produced merchant vessels. The Japanese admirals who had mocked American shipbuilding capacity lived to see their calculations proven wrong by the most decisive margin imaginable. The ships they believed could not be built fast enough were built faster than Japan could sink them. The industrial capacity they had dismissed as inadequate overwhelmed Japanese strategic planning. The nation they believed would be strangled by submarine warfare instead strangled Japan through industrial supremacy and unrestricted submarine operations that destroyed Japanese merchant shipping, while American merchant shipping multiplied exponentially. In the end, the Liberty ships represented a simple but profound truth about industrial warfare. The nation that can build more ships, produce more weapons, and sustain more troops will prevail if the war continues long enough for industrial capacity to manifest. Japan had gambled that the war would be short. that early victories would force American negotiation, that industrial capacity would not matter because the conflict would end before America could fully mobilize. Every assumption proved wrong. The war continued for nearly 4 years after Pearl Harbor. Early Japanese victories were reversed. American industrial capacity mobilized fully and produced equipment in quantities that Japanese planners had believed impossible. The Liberty ships, launched at rates of 1 every 8 hours at peak production, proved that impossible was merely a failure of imagination. American industry, when properly organized and motivated, could achieve production goals that exceeded pre-war assumptions by orders of magnitude. The workers who built these ships, the women welders and the farmers turned ship fitters, and the construction workers who applied their skills to maritime construction, achieved something remarkable. They revolutionized shipbuilding. They enabled military operations across the Pacific. They contributed materially to Allied victory. And they proved that when a nation's survival demands industrial mobilization, traditional methods and assumptions can be set aside in favor of whatever works, however unconventional. The Liberty ships were ugly, slow, and unsophisticated. They were also numerous, functional, and decisive. That was enough. Thank you for watching. For more detailed, historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.